Well, hi, good morning, and thank you for joining me here in my shop. Today is September 14th. So I ended yesterday's video having tried to determine whether the local oscillator is above or below the target frequency on each band. I got the result here on my note page. They're all below. The local oscillator is below the target frequency, except for one band. 25 meter band. I'm going to start right there this morning and try to prove that that's true. It seems kind of odd to me that the local oscillator would be positioned below on every band but one. So it could be the case, or I think it's much more likely I got confused. I found that quite a confusing deal yesterday. Maybe got a little too much going on in the shop here, and so that's where I'm going to start. 25 meter band. And I have to turn everything on and get it going. So I'm going to stop and do that. Okay, so the oscilloscope is really doing nothing of interest to us, but it is hooked up to the outside terminals of the volume control. But it's really the SDR where the action is. When you look on the SDR, you can see a red line on the waterfall. That red-yellow line represents the very powerful local oscillator. You can also see I have the pickup coil jammed in the radio here. This is just a kind of a random location in the area where I'm sure the local oscillator and other stuff might be. Having it shoved in like that can disturb these coils. So this is just a rough way to find out or verify the local oscillator. But in the meantime, I noticed another phenomenon, which I want to investigate a little bit. It may be totally meaningless, or it may mean something. Now, the handy thing about the SDR display is the waterfall makes it really easy to see small changes in the frequency of those signals you see, because the line will wiggle a little bit, and that wiggling is very easy to see. And I can probably just use my hand to demonstrate. There, see? There you go. Hey, let's try that with the bottom plate. Let's try that with the bottom plate. Now, this didn't seem to affect the IF at all, but I'm pretty sure it's going to have effect on this. Okay, I'm just going to kind of slam it up there. First, I won't touch the chassis. I'll just bring it up close. And I'll take it away. Well, there's no question there's a variation there. Now I'm going to bring it up close, and I'm going to tap it against the chassis to ground it out on and off. That's what I'm going to try to do. So we'll bring it up close. Oh wow, look at how much difference it's made. And I'm not exactly sure what we're seeing that's varying, but even the local oscillator is wandering. Now I'm going to tap this to ground it and try to make and break the ground connection. Now is that me just swinging it closer and farther? I think it actually is. I think the movement you see is me actually swinging the thing back and forth. Well, it certainly proves the sensitivity of something when it comes to this base plate being on there, so I better not get too precise. I better not get into too much precision here without that plate on. So, okay, now let's get on to 25 meter band. Local oscillator is currently floating up at 12, whatever that is, 12, what is it? About 12.29. Oh, what a lousy number. Okay, 12.29. So if I take my calculator, which I have, of course I've been straightening up my shop, so I don't know where anything is again. Oh my gosh, where'd my calculator go? It's a great big thing. Oh, I'm gonna have to do it in my head. So we're aiming, so the radio is dialed in at 11.8, which is well below, way below. So if we take 460 off of 12,290, we get 11,830. 11.8. Oh, that's not bad. That's roughly where it's tuned. It's above. So it does definitely show it above. Or is that backwards? or has this radio been so poorly aligned that this is totally backwards? It's very unlikely. If that were the case, then this radio would react to a signal 460 above the local oscillator more than it reacts to a signal 460 below. So we know what the reaction is. We'll get it on the meter here by dialing in the frequency. Here we go. So on the other signal generator there, I'm matching the tuning of the radio. Wow, it's just a hair trigger. There we go. Ooh, wow, it's really tough to. Let me just try this one. This is a little easier to do. Okay, so I got it at maximum there. The actual voltage is 7 volts negative for the ABC voltage. So now what I'll do is I'll move the signal generator up to, let's see, it would be 12,290 plus 460, 12,750. 12,750. And see if we get a jump on the meter here. 12,750. Okay. Here we go. 12,750. Okay, let's look back at the meter. Somewhere around here, anything jump up? Now there may be a little response. Yeah, see, there's a little response there. Let me come by it again. Right there. Very small response. Let me just sweep around here a little bigger just in case I'm being fooled. Go by it again. So small we didn't even see it. Oh, there it is. Oh, that's really big. How'd I get that big? It's because I dialed my signal generator all the way down to 11.8. So what we're showing is the image which is occurring above the local oscillator is highly suppressed by the radio compared to the signal that's below the local oscillator. That pretty much verifies that in fact the local oscillator should be above on this band. Now what's it with the other bands below? So I'm going to check that. The most important band for having trouble with images would be that broadband. So I'm going to switch to the broadband here, and we'll dial in 10 megahertz. We'll just repeat this. So if I've dialed in 10, actually it'll be on the SDR, won't it? If I've dialed in 10 and the local oscillator is below, then it's going to be 460 below 10, which is 99640, 540, 95 something. Let's go down there. 9. Bring this over here. So 95 something is right in this area. Look, we got this big whopper thing here. We got something big over here. So I'm going to wiggle the tuning on the radio a little bit, and we'll watch who's moving. Everybody's moving. Everything is on the run. So again, SDR. Isn't that strange? That's just so odd. I'm just tuning back and forth. It makes beautiful diagrams on the lower part. Okay, so some of those are fake. Some of those are accidentally generated by the radio. One of those is the real local oscillator. Yeah, all good questions. So let's just go back to what we're doing here. 10. Let's go back to what we're doing. Okay, so it's dialed in at 10. It's quite a warp on that pointer too. Now, if we're receiving 10, the local oscillator should be at 9,540. Oh, there's like nothing there at 9,540. So if it's on the other side, let's leave the radio tuned where it is, and we'll feed in a 10 megahertz signal, and we'll see what happens on the ABC meter. I had this feeling of confusion yesterday when I was doing this. Yes, feelings of confusion. Okay, we're around 10. Now we're gonna watch that meter. I really got a problem with this camera location. So there's a little pop. Okay, so there's a little pop at 10. Actually it's 9.9. So how would that factor in? 9.9? That sounds like 10. That sounds like the radio's just not tuned exactly to 10 like it shows on the dial. So now if there's an image, if this is the image, then on the other side of the local oscillator, feeding a signal in should produce a big result on here. That's the theory. So the local oscillator, we think, is running at where? I'm gonna wiggle this a little bit. Oh my god, I don't know. Everything's moving. There's 9 local oscillators running in this radio. Well, the biggest one is most likely the correct one, and that's right near 9.5 on here. So, so if the radio was tuned to 9920, and you subtract, where's my calculator? Subtract 460 from 9920 is the same as 440 from 990 is the same as 400 from 98. I've lost it. You know, the copy just isn't working anymore for me. Where is that calculator? I had it. Here it is. There it is. Okay, turn face down. I'm looking for something white, and all you can see is something gray. That's why I couldn't find it. Okay, let's do this calculation now. What is it? What are we doing? So we got it. We think it's receiving 9920. 20. Oh, come on, you crazy calculator needs some light. There, that's enough light. It is pretty dark in my shop, although it doesn't look that way in the camera. It's actually quite dark in here. So we want to do 9.920, so 9920. And if the local oscillator is below, then we've already taken care of that. We want to add 460 onto this. No, that's not right. That's not right. Yeah, see, confusion is setting in. It's too much stuff, man. There's a video going. There's camera images. There's multiple lines on the SDR. My poor little brain is just suffering something terrible. Quick, more coffee. Oh, that fixed it. Sort of. Wow, I really lose my mind when I'm doing this stuff. So the radio dial is set right to 10. Now that actually makes the radio receive 9920. And the local oscillator, if it's below, let's do it this way, if it's below 9920, then it must be at 9460. And you know what? I think that's exactly where this is. 9470. Okay, that's close enough. So that's the local oscillator without a doubt. And it's mixing with 9920, even though the radio dial is set to 10. That's okay though. So right now, right now the way the radio's aligned, it's responding to it's tuned for maximum when the local oscillator is below. Is that correct? if it's not correct, then we would find, you know what, the local oscillator cannot be above and be in this band at this frequency. This is a band spread. It only goes from 11.6 to 11. To, let's say 12. That's a very small amount. I don't think you can get it wrong. Because if you do, then the signals you're picking up would be way out of the band on the front. Well, you know what I'm going to do? Because my brain is not keeping up with everything here at all. Whoop, 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 whoop. There. Yeah, I'm really losing it. I'm just going to sweep with the signal generator slowly through a large range of frequencies here that might be worth doing. That's what I'm going to say. Okay, I'm just going right down to like 8. Okay, at the bottom I can go on this 9.2 is where I'm starting. Just watch. I'm going to give it some more juice. Just watch that meter. If I cross anything, it's going to jump up. Oh, yeah, right. Just as I look away, because I'm thinking this cord is annoying, the meter jumps. There, that's a little better. Okay, so here's something that is producing a signal out of the IF, making the ABC jump up. Wow, this is really sensitive. And that frequency is, it's that same frequency, 9920. So this is 1. This is the one that produces the 7. It's right up around 7. Okay, is there another one? Is there another one? Whoa! There's another one right. Oh my gosh, what was that? So you can't tell what I'm doing with my hand, but I can tell you what I'm doing. So it's 9900. I'm going to go up past 20, and then right around 9930, another peak shows up. Here we go. We're going up. Here comes the first one. Okay, so that was 9920. Goes down. I'm continuing up in frequency, and it. Oh, for crying out loud! It doesn't do anything. What did I do there? Is it just my shaky hand? No, there's two things there. You see that? I went down. There were two swings up. Let's go up again. Just do it slower. Okay, first one coming up. Going down. Coming up. Going way down. And so it's pretty hard to see, but there is two little peaks in there. But they're both right around 920. So that's not what I'm looking for. I'm looking for something 460 kilohertz away. Or even 920 kilohertz away. I'm turning up the frequency and just watching that meter very hawkishly. Okay, we're way up into 11 here. 11. Oh my god, I'm so confused. I've looked at the wrong band. No wonder these things go haywire in here. The great thing is when I do this alone and it's not on camera, I don't make a single mistake. Not a single mistake that I'm aware of. Going back down. Down to, oh, okay, we're at 9920 again, produces the big one. Going down. Down, down, down. And you know what? This is only going to go down to 9.2. So we're at 99. And I'm going to go almost a megahertz down to be sure. It's right on the band change of my signal generator. Okay, so I got to go way down. Now we're coming low. So that little bump right there, that my signal generator is at 3.3. 3.3 shows that what this means is if there's a real signal on my antenna at 3.3, when I have the radio tuned to 10, 3.3 will come through. That's what that's suggesting. The radio's, how could it possibly do that? I don't know. Let's just keep going up, up, up. 3.3. What is special about that number? Okay, we're up to 4.3. Oh, there's another little bump. Wow, it's extremely precise. This is 4.9. It's just a world of interesting things going on here. I find it interesting anyway. Going up. We're at 5.5 now. Going up. I mean, who would have think a frequency that far away would make it through the radio? I wouldn't. We're at 6.5 now. Still going up. Oh, there was a little thing there. I don't see it now. Okay, continue on my way. It was very small, whatever it was. Could be other things happening. Okay, the interference sounds. 7.2 now. Just don't want to go too fast. I'm going to go right past a sensitive point. .7. So if this meter swings above, say, 9 or 10 volts, then holy smokes, I don't expect it. I expect that radio to be correct. I have found them backwards. I have done them backwards. So I know the possibility is here. There's a little bump there. So now we're at 9.0. Still going up. 9.5 now. 99.20 is when it usually. Oh, there we go. And that's the 99.20 spot. There's nothing that compares to that out here. Okay, so we swept this thing above and below. So it's true. It's below on some and above on 25. Now we know. Now we know. Okay, so I got to stop and think for a little bit about how to go about doing the next stage of the realignment of the radio and get the best result. The situation with the IF, where when I use the sweep approach, I got a different result. I got quite a different result. Can't explain it. Don't know how that happened. Don't know why. So I did do a couple capacitors, maybe after doing the initial IF alignment. I think I did a couple capacitors around the volume control. I don't know. I don't know what it is. Who knows? I don't know. I lost track of all that. Just a question mark in my mind. How come so far out on the first alignment as compared to the second? Maybe the same thing's going to happen now. Plus no plate, no plate. I got to think about that plate. Hey, all the other alignment activities are done above. Yeah. Okay. Okay, let's see what kind of mess I'm in now. So you see I brought down the output meter. The reason is I put the bottom plate on the radio. So if there's any influence, it'll be there while I'm doing these alignment activities. And in doing that, of course, I sealed off my access to the AVC contact point and things like that. So, you know, with a lot of these radios during alignment, the recommendation is you just monitor the output at the speaker. Well, that's a problem with this radio because there is no output at the speaker, and I've got the two output tubes pulled out of it, in fact. But what there is a output signal on its way there from the detector tube. So what I've done is, you can see in the back here, one of the output tubes I put in what's called a tube extender there to give me some terminals to clip onto, and I've clipped that red clip lead onto the grid of the output tube. That's receiving the output of the detector tube. That should represent what's going to the speaker, even though it doesn't get there. And of course that red lead is coming right over to my output meter here. What I don't know is what kind of signal's on that grid, and I also don't know for sure what kind of influence this meter might have on the circuit. Maybe this is too low impedance. I attempted to measure this. The impedance appears to be really high. So maybe it's a 10 meg on the input. It looked like it's even much higher than that. So we're going to find out. We're going to find out by trying it. I'm not going to hear anything just yet, but I'm one step away from listening to this radio again, just by sneaking the output from the same place the meter's picking it up and just sneak it off to an amplifier and a speaker or something like that, if we really want to listen to it. But what we do want to do is turn it on at this point. Here we go. So maybe the first thing that's difficult here is I've done this without putting a capacitor. There's a, just watching the voltage. Now that could be audio. That could be some AC signal in there. It could be a DC signal too. So again, we can't hear the radio and we can no longer see the ADC voltage. But the radio is tuned to 10 megahertz. And we're going to move the signal generator. Just rearrange things a little bit here. We'll see if we can make this meter pop up at some particular frequency here. This is a modulated signal, so it's actually the tone, and I need to put the volume up. But yeah, I need to put the volume up. Look at that. That makes a difference right there. Dirt way up high. Yeah, I think there's just a little bit of dirt up there. So, okay, so far everything seems normal. Here we go. Will this meter jump? The answer appears to be no. Oh. Is that from me? Something else doing that. What about tuning the radio itself? Oh! I'm going to have to put this on a speaker because we just have no idea what is happening. Okay, that's going to take a little bit of thought on how to do that. Oh, what was that? I'm going to guess if we could hear it, it would be crackling from what? I don't know. Broadcast band, no antenna. Yeah, let's stick a little antenna on there and just see if we can see some noise or something. Maybe I don't have to hook up a speaker. Yeah, eventually I'm going to have to, aren't I? So I want to put this on the antenna. I think it's that one. So it's just a wire. Whoa, just a wire here in my shop. Obviously that's not the radio that just made that sound. What are we watching? Watching the output meter. Yeah. So I think it's picking something up. Some noise or something. Excellent. Okay, so I think this is working. So if we go back to, let's say 10, we know when this is dialed on 10, it tends to pick up a signal at 99.20 or so. Let's give that a go. And watching this meter again. Moderate signal. Wow, wait a minute. No wonder the thing didn't work the first time. I never actually hooked up the signal generator. Let's hook up the signal generator here. Output down. Yeah, I'll try that again. Okay. 922, something like that. Low strength. Oh yeah. Do you see that? Oh my gosh, it's like a hair trigger to tune that. Well, you gotta wonder what all that scratchiness is. Yeah, we're gonna have to hear this. Behaving in a very odd way. But despite all the waving, if I ignore the meter waving, I can see the high points right in here. 9.862, 9.5 is what this is. Oh man, you know, I would really like to hear this thing making its sounds. Yeah, you know, I'm going to stop and I'm going to figure out how to make this thing make some sound in here so we can hear it. Okay, what I've done is I've dug out this Heathkit mono amplifier I built in college to be used with a college radio station, which is an interesting story, but I won't go into it. And we're going to use this to power a speaker that's sitting right here, precariously sitting on top of the other speaker. These are the wires to the speaker. And we'll put them on here. We'll try to put them on there. Should do. And put there. Have a nice cable for that. We can now put this, basically the same signal that's going to there. So I can hook it right up to the meter here. Put this into its place. Yeah, come on. That bench is getting too messy. First turn this on, it generates quite a loud hum. This is flips the down, turns on the speaker. Up just leaves the headphones going. Let's hear the hum. Gotta plug it in first. That would help. Grounding on this. This is a isolated guy. Ooh. You know what? I'm going to plug it into my... is that a good idea too? No. I was going to say I'll plug it in the isolation transformer along with this. But... I think what I'm going to do right now, it is not connected to anything but a speaker. So plug it in. Okay. Let's hear the hum. There it is. Okay, everything's good here. Volume down. We just want to check to make sure there isn't a voltage between here. Just a safety thing I'm uncomfortable not doing. Because regardless of what I might think, the truth is not necessarily what I think. So we're seeing 50 volts. That's okay. And 50 volts doesn't come with any power. 50 volts will disappear the moment I attach this. Famous last words. Yeah, okay. Just ignore that effect. Okay, no big sparking excitement here. Oh, I gotta get going on over here. I want to hook it on right on here. That's a little awkward, but that's where I want to do it. How am I going to do that? Like that. Hang on. Okay, get on there. Well, I think we're going to hear something now. Blimey. That's British for holy smokes. Success. We've had success. The eagle has landed. What? So I'm pretty sure this is 9.330. We're listening to shortwave. The antenna amounts to this piece of cable. What does it amount to? It's just hard to believe. The antenna is the lead to my signal generator. So 9.330 is an extremely powerful shortwave station that I can pick up here from time to time. Actually, a lot of the time. Let's see if I can tune this just a wee bit better. Should be able to pick it up again. 9.4. No, 9.3 is way out here. It's off this band. Got this working right though. We're golden here. Hey, it sounds great. What's the problem? Clearly something going wrong with the bass control here. I'm gambling this music is not copyrighted. Bad gamble. Wow, this is great. Don't do any more, Jim. You've done enough. I guess they're just filling in time. Let's just see if we can pick up anything else, just for fun. With no antenna. Virtually no antenna. No, just have one. It really does stand out. I think I could light a light bulb off my antenna when that signal's there. Okay, are we ready to actually try and do something now? Having discovered the radio is actually working pretty well. So we have the option of altering the oscillator and altering the RF adjustments. Should start right back at the start at this point. Oh, okay, you know what? I'm going to go a little further. I'm going to do the broadcast band on the radio. I put a light bulb in there for phonograph. Wow, it's really beaming out of there. There we are. Broadcast band. Let's tune this. I'd be stunned if we pick up something, because there's really not much of an antenna here. Let's give it an antenna. So take off the signal generator. Find my antenna wire here. I just won something. What did I win? Okay, I'll put this antenna connection. I'm just putting it on the antenna terminal here. Didn't seem to make any difference. Surprised we're not getting anything. Whoa! Whoa! So what happened there is I removed the ground lead from my antenna wire. Why it improved it? So we're checking dial accuracy now. So this is, I believe this is 640 showing up at 590. 590 is generally a stronger station than 640. Okay, so I'm going to beat my generator against this and find out what we're really, if it really is. I don't think it's 590. 590 is almost always sports. I'm not going to get down there. No.
Over 60 people were infected, remains on the QT. Dr. Mark Howe, the acting medical officer at Health Field, telling the Star that disclosure policies have evolved since the Maplewater case. But Brandon Mayor Patrick Brown telling Senator Trailer earlier today he doesn't think we should have different thresholds on what's being disclosed. Branson and Mr. Saga are very intertwined with families, neighbors, friends, and so we're all part of Pure Region together. And it's my belief that if you're nearby
640. Okay. I know 640 showing up at 590. Now I did not do the oscillators first time around. So let's do it with the radio station instead of the signal generator. And I need to figure out what to do here. So at the low end, the oscillator for the broadcast adjustment is this one here. So we're going to try to move the pointer and get that same station to be at 640. We'll look at the way we want. Adjust the oscillator. All the way we want.
Basically ordering through.
See how much louder it got? It's just, I'm sure you did. 640.
COVID-19 in Canada will be among the key topics in Ottawa. Prime Minister Justin Trudeau's cabinet retreat starts.
640 here, but there's another trimmer at the high end at 1500. There's no station at 1500 to work with. Radio seems. Remember, in the last video, I discovered that the radio was very quiet at this end and quite powerful at this end, and I think I just corrected it just by altering the local oscillator and bringing the reception in line with the front end. That's kind of what I did. So we're right on 1500. See if we can heterodyne this in. We'll hear it. It doesn't heterodyne. Just want to hear it. Okay, output of the signal generator here, down, 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 down. Just want to lay it in really close to where the antenna is. Yeah, just turn it around like that. Maybe I'll. Can you hear it now? So I'm loose coupling the signal generator to the radio. We're very close here. So now I'll adjust the oscillator trimmer for the high end. It's a capacitor. It's on the outside. It's right here. Barely see anything in here. Okay, so that's in place, and here's a little signal on here. Turn the volume up to get it there. There we are. Now, the objective here is to leave this at 1500 and get that to say 1500 with the meter maxed. Okay, we go towards where we want to go, and then find it. This capacitor is wide open. So we're kind of in the same place that we were last time. Can't make the top end line up. It could be because the bottom end is moved incorrectly because the top end was way out at the start. I'm going to try this again. So we're going to close the capacitor down. Wow, it goes a long ways. Okay, so it's really closed down tight. Go down the other end and do the station. Assuming you can still hear it. See where it is now? It's there because I moved that capacitor. Now let's see if I can use the inductor here and move this more appropriately. So we want this to be up here at 640. Just fading right out. So I misaligned the radio, something terrible, but there's other alignment elements that may bring it back. So let's just see if we can make 640 show up where it should. Oh my gosh, I can't even hear it. Okay, there's 640 where it should be. Now we'll see if we can do better at the top end. 1500. Oh my gosh. It didn't go well. Okay, we'll just start opening up the capacitor and see if we can move this up. But you know, I think this is exactly what I did last time. I just ended up kind of in the same spot. It works good on the bottom, but not so good on the top. It really, really moved. Not a very good result. Okay, so I don't like what's happening here. I think I'm gonna just concentrate on this end because that's where all the stations are around here anyway. It's Let's go back down there and see what damage we did here. Now it's way up here. Nobody else, eh? Yeah, I'm going to push that back down.
So if I'm to the top, I might pass it on. Like, chance of me passing on one person is very low. So what we're saying is the R rate, the replication rate, is going up. And we don't want that to happen. Today, the number, 313.
Right, and we're seeing that R rate, that number of people who are getting sick from each individual who is sick, has been over 1 through this time period too, and that's why we're seeing the numbers increase. So
really close. Can't get there. So that's screws ready to fall out of the capacitor. So that's just all I can get there. Let's move it again.
Just follow the guidelines of one. Everyone will be okay. Okay, everybody good? We all in the spot? No, because people are doing it right now. You need to be talking tougher. You need to stay. In Ontario, we've seen the numbers in
Another station now. $590. 640, 680. There it is. 840. Might be a little loud for the video, I just realized. But I can't get 840. Well, we're picking up 590 now. I'm going to fiddle with the capacitor at the top for a minute. It's wide open, so I know where it is. Back to wide open. Okay, next thing to do, assuming that's alignment, the oscillator part's done. The next thing is broadcast RF trimmer, broadcast antenna trimmer. Okay, try those. Those are, here, just look on the screen. Can you see it? The two trimmers are here. towards the... Just doing it by ear again, towards the...
I go to the grocery store now. People have their masks on where their nose is exposed. Just take it off, I guess. And you can just take it off and see it in. People are working on it. Like, oh,
No wonder it's dark in here.
not good enough. And I think
I never turned up my bench lights.
I'm not interested in going backwards, William. I kind of like being able to go out again.
Okay, here we go. So get louder. Hearing any difference. That's not good. Should do this maybe at the high end. What does it say? Yeah, I should be up at the high end doing this. Okay, we'll go up to the high end. There's our 15. Pretty much right on. Actually, it's 1481, isn't it? Get it maxed out here. Watching that meter now. Just a little more volume. Okay. So the actual signal's quieter than the noise. I can fix that. I think I can. There. That's a little stronger. That meter's working backwards. That's as good as I can do it. Now, what variation do we see in this meter? Just a bit more volume. Hold still. Oh, I heard that. Okay, that's pretty tight on that one. Next capacitor. Trimmer. Big trimmer. Having some trouble with the UVC active here. That's open all the way. Hold still. So that's just below the 2. That's a 2. Going down. That's the spot. There's a French station up here I use a lot. Too loud. Not finding it. Okay, we'll try down here. 680. It's there. 640.
They're working hard.
Right there.
Exhausted. I don't know when these guys have had a day off, if they've had a
610. No. Do much noise. 590. It's not going to get much better than it is, I think. Okay. Here we are. So I'm going to leave it at that. I think I'm pretty happy with what's happened here, as much as I'm kind of screwing around with it. And then tomorrow, the other band's done very carefully, bottom plate on, everything done to get the very best out of it. And we'll see what we got.